This video is going to cover section 1.2 notes, which is some basic rules for exponents. Okay, let's kind of go backwards a little bit when we get started. Let's start with letter C here, the exponent rules, and then we're going to go back to that example that's at the top. So let's think about some basic exponent rules that you should have learned back in Algebra 1. So number one, I already have completed here. And the idea is if you have x to the third, right, that's the same as multiplying x by itself 3 times. And if you want to multiply that by x squared, that's the same as x being multiplied by itself 2 times. Then really, don't you have these 5 x's that are all being multiplied, right, which comes out to be x to the 5th. Well, the rule is that anytime you multiply 2 exponential terms where they have the same base, notice they both have an x, then when you multiply the same base, you actually just add your exponents. Okay, so we could have from the very beginning said, oh look, if I add my exponents, it's just going to give me x to the 5th. Okay, so what's the meaning behind this one? Well, x to the 5th on top, so you have these 5 x's being multiplied on top, and x squared on bottom, so you have the 2 x's being multiplied on the bottom. Well, you all know whenever you have the same thing on top and bottom, they cancel. So all you actually end up with here is an x to the third, and it's on the top. Well, again, the idea is if you have some power of x being divided by another power of x, the shortcut is to just subtract those exponents, right? Top exponent minus bottom exponent. The next one, so I have an x squared and that's being cubed. Well, if I'm cubing an x squared, that means multiply x squared times itself 3 times. Well, according to what we learned in the first example, whenever you multiply the same base, you add your exponents. So if I multiply those and add my exponents, I'm going to get x to the 4th. And then if I multiply that by the x squared, add my exponents, I'm going to get x to the 6th. But what the rule is, if you have one power of x, I didn't want a 2 there, I wanted to write it generically, we'll say an m. If you have one power of x and then you raise it to another exponent, the shortcut is you would just multiply those 2 exponents. Okay? I'm going to kind of skip some of the meaning now, and hopefully you kind of remember some of this. So the idea on the next one is if you have a parenthesis, then that exponent has to apply to everything inside the parenthesis. So this would come out to be x to the third and y to the third, right? And really the next one is the exact same rule. It doesn't matter if it's a fraction. If it's in parentheses, that exponent on the outside applies to both the top and the bottom. So you actually have x squared over y squared. Okay, how do we handle negative exponents? Well, keep in mind, you never want to leave a negative exponent in your final answer. We just don't consider it to be simplified. So how do you get rid of negative exponents? Well, basically you move them. So this one right here, if you have an x to the negative 2, if I move that to the denominator, it would be an x to the positive 2 in the denominator. Well, what if it's already in the denominator and it's negative? Well, that's fine. If you want to change the sign, you would move that up to the top, and so that's the same as having an x to the positive 2 on top. So negative exponents are easy to fix. You just move them from top to bottom or vice versa. The next one, I think you all would look at this and recognize, hey, look, when you cancel something with itself, what does that equal? It's not 0. It actually equals 1, right? But what I want you to see is, if you think about that idea of subtracting, remember we said if you have a fraction like this, you can subtract your exponent. So it's kind of like saying, hey, I'm going to have x to the 2 minus 2. Or in other words, really what I have is x to the 0. And so there's a rule that says if you have, I'm going to move this over here to this section so we can kind of call it a rule. And that is that anytime you have an exponent of 0, by definition, it equals 1. It just automatically equals 1. Okay? So let's look at some examples. Well, this is a fraction. So I'm going to subtract my exponents. And yes, you could say 3 minus 7. So one way to look at it is to say, oh, look, this is going to be a to the negative 4, because you would do 3 minus 7. And we don't leave negative exponents, so it's really going to be 1 over a to the 4th. That's true. But what I'd rather you do is I'd rather you think of this as the idea that just picture in your head. Okay, so you're not writing this, you're just picturing this. Okay, here it is. This is just like a little thought cloud in your head, right? What you actually have is this a to the 3rd on top, and you have a to the 7th on the bottom. Well, you know you're going to have some canceling, right? And you know you're going to have some leftover. So you just ask yourself, well, where did I have the most, right? Didn't I have more a's on the bottom? So doesn't that mean that the 4 that are left over are actually on the bottom? And you shouldn't really have to write this out to see that. Okay? Sometimes exponents, it's, smarter to kind of think ahead of the game. Okay, so that's a to the 4th. The next one, so I want to simplify it, and remember, I do not want to leave any negative exponents in my answer. Well, first thing I would say is remember how whatever's outside of a parenthesis, it applies to both of those, right? So I actually have 2 to the negative 3 and then 5 to the negative 3, okay? But remember, we don't like to leave negative exponents. Well, if I want this one to be positive, it's going to move to the bottom. And if I want this one to be a positive, it's going to move to the top. And in this case, well, I know what 5 to the 3rd is. It's 125. And I know what 2 to the 3rd is. It's 8. So sometimes when we have numbers that have exponents, I'll expect you to actually go ahead and multiply them out. Okay? Okay, so speaking of simplifying exponents, which ones would I expect you to simplify without a calculator? Well, we've added a page. Right now we're on page 10. I've added page 9b. Basically, these are the ones that I would expect you to know without a calculator. Now, I started over here at 11. That's because I assumed that everybody would be fine on, up through 10. Like, you need to know that 9 squared is 81, or that 5 squared is 25. So you definitely need to know 1 through 10. But you also need to know these. You need to know that 11 squared is 121, just off the top of your head. You need to know that 12 squared is 144, that 13 squared is 169. Some people are pretty good through 13. Definitely through 12. Some are pretty good through 13, and here's where they kind of fall off. Well, 14 is easy if you know 13, because you just switch the numbers. It's not 169, but it's 196. 225, you know it has to end in 5, right? Because it's a multiple of 5. So 15 squared is 225. Now 20 squared might seem hard at first, but just think about it this way. 2 squared is 4. So 20 squared is 400. And then 25 squared is 625. Now I get that probably these aren't as familiar. That 20 squared, even though you might not think about knowing it, it should seem easy to you. So okay, so there's 3 that might take a little bit of, memorization. I expect you to know the cubes up through 5, right? So 1 cubed is 1. Basically 1 to any power is just itself. Okay, 2 cubed, so 2 times 2 times 2, you need to know that that's 8. 3 cubed is 27, right? 3 times 3 times 3. 4 cubed is 64, you need to know that. 5 cubed, we mentioned, is 125, okay? So again, maybe a few of those you're not as familiar with, but you need to become familiar with them. And then these to the 4th, well, like we said, anything to 1 to any power is just 1. But these seem harder than they are, because remember how we said when you multiply the same base, you add your exponents. So think of this as like 2 squared times 2 squared, right? Because you would add your exponents, that's 2 to the 4th. Well, isn't that just going to be 4 times 4? Or 3 to the 4th, think of it as 3 squared times 3 squared. Yeah, that's 3 to the 4th. But wouldn't that just be 9 times 9? So you might not think you know them off the top of your head, but if you think about it for a second, they're easy to get. Okay, and then these negative exponents, well, you shouldn't have to memorize, because if you know these, then you know the negative exponents, because remember, negative just means put it in the denominator. So 2 to the negative 1 Well, what is 2 to the first? Isn't it just 2? Negative exponent means it's in the denominator. So what is 2 squared? It's 4. Well, negative exponent means it's in the denominator. 2 cubed is 8, but if it's a negative exponent, it's in the denominator. 3 to the first is 3, but it's going to be in the denominator. 3 squared is 9, in the denominator. 3 cubed is 27, in the denominator. So again, those come from knowing most of these. So it may look like I'm asking you to memorize, but I'm not. Most of this you should already know. A few things you just have to kind of get settled in your head. Okay, so back to our examples. Number 3. Well, whenever there's negative exponents involved, my suggestion is get rid of the negative exponents first. So if I want to make this become a positive exponent, I'm going to have to move it to the top. Well, there was already an x on the top. I'm not touching that. But I'm going to move the y squared to the top. And when I move it to the top, there's nothing on the bottom. So I'm done. Okay, on this one, now here's what I need to think about. I don't want a negative exponent, but I also have to apply this 4 to everything in here. So why don't we take care of the 4? So that means I have a 3 to the 4th, but then this x, when I raise it to the 4th, remember you're multiplying exponents, so it's going to become x to the negative 8. Okay, now be careful. Yes, there's a negative exponent, but the only part that has a negative exponent is the x. So that's the only part that needs to move to the denominator. That 3 to the 4th, which we now know is 81, stays on top. And now the x to the 8th goes to the bottom. Okay? On this one, there's a lot of things going on, but let's start with a little bit at a time. First of all, this 3 applies to everything in the parentheses. So I've got a 3 cubed, well that's 27. And then when I raise my power to a power here, I multiply, so that's x to the 6th. And then I still have this 2x cubed. Now I know it was in parentheses, but it doesn't need to be in parentheses, right? It's just being multiplied. So when I multiply, 27 times 2 is 54. Then when I multiply x to the 6th times x cubed, remember you just add your exponents, so x to the 9th. Okay? On this one, I realize it's easy to look at this and say, okay, well, start with 4 squared is 16. But if you do that, then you're going to have to do 16 cubed. I don't know what that is off the top of my head. So maybe what you should do before you multiply out your 4 squared, maybe you do this thing, right, where you're raising a power to a power, so you multiply exponents. So I've got 4 to the 6th over 4 to the 5th. So think of the 4 as just like your x, right? When you have the same base, can't you just subtract your exponents? So 6 minus 5 is 1. So that just comes out to equal 4 to the 1st, which is just 1. Okay? What about number 7? Well, that 4 applies to everything inside. So I have 2 to the 4th, I have x to the 8th, right? Multiply your exponents. And then on the bottom, I have 5 to the 4th. Well, we talked about 2 to the 4th. That's just 16, x to the 8th. Now, I don't expect you to know what 5 to the 4th is. So if you want, you could leave it 5 to the 4th. If you want, you can, if you realize that, hey, that's just going to be 5 squared times 5 squared, which would be 25 times 25. So if you realize that is 625, fine. But you don't have to. It would be fine to leave that as 5 to the 4th. Okay. Got a lot of negative exponents, but I also need to apply this to everything inside. So I'm going to do that first. So I'm going to have x. If I multiply my exponents, it's going to be a positive 2. And then I have y to the negative 2. In the denominator, that x squared, if I raise it to the negative 2, becomes to the negative 4. Now, my suggestion here is to get rid of your negative exponents first. Okay, so if I get rid of my negative exponents first, that x squared does not have a negative exponent. It stays, right? That y squared needs to go to the denominator. And then this negative exponent needs to move up. So I'm going to have an x to the 4th on top. Now I can simplify and say, oh, look, on top I actually have x to the 6th, and on bottom I have y squared. Okay? All right, let's take a look at 4 more. Actually, you know what? Why not? think I'm going to let you guys do number 9 yourself. And the one thing I would mention about number 10 is maybe before you try and do anything with that 12, you just take care of all your negative exponents. I think that might be smart. So let's leave the 12 to the 5th alone because it does not have a negative exponent, right? That y term needs to go to the bottom to make it be a positive exponent. This 12 would come to the top, so it's going to be like a 12 to the 1st. And then this y needs to come to the top, so it's going to be y to the 3rd. So if I add my exponents, 12 to the 5th times 12 to the 1st would be 12 to the 6th. Now look at this, I have a y to the 3rd over a y squared. Couldn't you subtract your exponents and you would have a single y on top? And remember, I don't expect you to know what 12 to the 6th is, so just leave it. And then look at number 11. Okay, I would say one of the most common mistakes I see in all of algebra would be a student who looks at this numerator and says, oh, that 8 applies to both, so it's x to the 8th plus y to the 8th. Okay? No, 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 no. You're like, hey, you just said if there's parentheses, it applies to everything. So let's talk about the difference in two different things. So I want you to compare, let's say, x plus y squared. I want you to compare that to x times y squared. You may remember up in our exponent rules, we did this type, right? If you go back up to the exponent rules, where'd you go? Right here, right? We did the type where they were being multiplied. We never had anything where the inside was being added, okay? Because yes, on this one, the 2 applies to both, right? X squared, y squared. But if this is addition or subtraction, you don't apply that 2 to these separately. You would have to think of it as the entire x plus y, and if it's squared, doesn't that mean it's multiplied by itself? And when you look at it that way, you would have to multiply it out and use FOIL. Okay, so make sure you don't get those mixed up. So on number 11, I can't distribute that 8 to both the x and the y. Now what I can do is I can say, well, I don't want negative exponent. So I could move this to the top. So in other words, the x plus y that's already there, I'll leave alone. The one that's on the bottom, I'm going to move up and say to the positive 8. And now I can look at it and say, well, look, don't I have the same base? Isn't this base the same as this base? So can't I combine them and say, okay, it's that base to the, add your exponents, 16th. So that would work to do that. Okay, this one looks very intimidating, but if you just apply the -5 to everything on top, apply that 5 to everything on the bottom, everything kind of simplifies nice and neat. And I'll let you try that one. Okay, so that takes you through the exponent rules for 1.2. One thing that I will warn you about on these is, yes, do your best to get them, but it's really going to be important for you to check your answers whenever you're given the answers, whether it's in class the next day or when. Because on these, it's easy to assume you're doing them right and really make a lot of little mistakes. Okay, so that's kind of my little warning on those.